All right, well, good evening. Thanks for everybody coming out, especially in the very cold weather here. I have to start off a little humble. That's the first time I've ever been introduced for any talk in my whole career. So that's a good start. Well, I'm glad to be here. First, I want to say, if I forget to say thank you at the end of the night, thank you to General Metcalf and the whole Aviation Museum staff here. They were wonderful setting this up and making me feel relaxed and getting ready for it. So thank you very much, sir, and to the whole staff for helping me along. I'm going to talk a little bit about how I got into UAVs, what a little bit I did, and what some of the challenges are for the future. I wish I had time to talk about the whole history of UAVs, but would have to go back to the Civil War and all the way to this point. So I'm going to concentrate pretty much the mid-90s where I picked up and some of the challenges in the future. But there's a ton of history here at the museum. We have some of the first ever UAVs, and they've even got one of the latest, the AV-3, the last Global Hawk. That's an actual combat-tested bird and test bird out there that I got to fly, and I'll get into a little bit more of. So when did I first get my introduction to UAVs? Started in the mid-90s. I was C-130s at Pope Air Force Base, and the first UAV assignments came down for pilots. Now, you would think people would want to go do something new and exciting. These first assignments were the dread disease of pilots. Nobody wanted them. People were forced upon them. And you felt really bad for the first pilots who got them because it was like leprosy. It was like nobody wanted to talk to them because they were being traded to a non-flying team. And they disappeared very quickly. And so my first introduction was, that's an assignment you don't want to go to. So guys disappeared, didn't hear from them. But then later on, I had the opportunity to go through the C-130 Weapons Officer School. And at the end of it, all the different weapons officers from every weapon system, from B-52s to B-1s to Strike Eagles, you get together for a massive exercise at the end of Weapons Officer School. And the first day of Weapons Officer School during the massive employment was actually a non-combatant evacuation operation mission. The idea was you had Country A and Country B going at each other, and the first day was to go in and get the ambassador for your country out of the other country. So for C-130s, we had, the first 2 days was all about us. We had to go in and get the ambassador and his family and all of his staff. So everybody got to support us for a day. Well, one of the first supports on that was a Predator was going to watch the operations during the first day. So we had to sit down with the Predator guys and talk about, well, what does that mean? And what we found out was going to happen was we flew into Country B. We were A and they were B. We flew into Country B. And we had to land at a field out in the middle of the desert, and we had to simulate picking them up. But the Predator was going to be flying above us the whole time. And what the operation was is that the commanders on our side would be able to get a full motion video live feed of the ambassador being picked up. Well, this kind of caught my interest quite a bit because there's some powerfulness in full motion video that your commanders up to the president in an ambassador situation would get a live feed of what was going on. Of course, we were a little bit bothered because that meant the president could also see our landing and if we messed that up or not. So there's another side to, you better get it right. If you go around, the White House could call and want to know why you messed it up. So after I graduated Weapons Officer School, I was very interested in Predators after that. And my brother, who happens to have been also a pilot in the Air Force, he was a commander at the same base at Little Rock where I got to be stationed. His ops officer, when he was a squadron commander, gentleman Duke Bender, was actually one of the first 15 Predator pilots who got to go to Nellis and fly the Predator. So I started thinking about my next career move, and I sat down with Duke, and I sat down with my brother, and I started saying, hey, maybe I could make a move to UAVs. Maybe there's a future in UAVs. Some people think these are kind of a maybe good system to go to. So I spent actually a year and a half doing research on the Predator and other UAVs, and what would be the possibilities of going to maybe Predator and doing that. And things lined up, and I had a chance to volunteer for a UAV assignment. So I put in my paperwork. I had a very good commander able to support me and try to get me to go to the assignment. Now, I picked up the assignment, and I was going on my way to Nellis pretty much. And then the week before we closed out and got my orders, an advertisement came up on the Air Force system. There was a new weapon system called Global Hawk at a Beale Air Force Base. Well, I didn't know where Beale was, didn't know what a Global Hawk was, but I thought, I'm going to something new, let me go to something new and try Global Hawk. So lo and behold, they were still taking first cadre folks out there, and so I got an assignment, and in December of 2002, I had the opportunity to show up at Beale. I showed up at Beale, dragging my family out there, like many officers do. We dragged our family from base to base. showed up at Beale, thought that we were going to have a very slow ramp up, bringing the Global Hawk into the base. And this is probably where things rapidly turned. There was no slow ramp up. Within 90 days of starting work in January, we got notice that the first OIF was going to happen, and we knew about it before. And we started preparing for it, deployed the Global Hawk, and I found myself doing a very short notice combat qual in the Global Hawk on the fly. I was very lucky to have Northrop Grumman instructors actually teach me why we're on the way to combat, how to fly the Global Hawk, why we're going over to the Middle East. It's a whole different perspective to fly with first-generation instructors of an aircraft. I was at Edwards Air Force Base. We couldn't even bring planes up to Beale. We were flying them directly from Edwards to combat. So I'm actually at Edwards. And this is the level of guys I got to train with. I'm up in the nose wheel, and my instructor, Brad Norman, a great Northrop Grumman pilot, looks at the nose wheel and he says, "What's special about this nose wheel well?" I'm thinking, okay, what did I miss in academics? I forget. I said, "Brad, I forget what's important about it." He goes, "I designed it. This is my nose wheel well." So he had actually been an engineer, got picked up he was a private pilot. He actually designed the wheel well. So I had the opportunity to be with guys who literally were with the plane for years and years before it got to fly. So I had the opportunity to do a combat upgrade. Now that sounds really cool until you're flying the plane solo over Baghdad, and it's not so cool. You're actually praying that nothing flashes or zaps in front of you that you can't handle. So you're just hoping that nothing happens like losing the engine, which was the biggest concern, and that you wouldn't know what to do with it. And so I got the opportunity from there. Now after that, it was kind of a marathon. It was a marathon run after that, and nothing ever really stopped. These are the big three we talked about: the Predator, which I got to know a lot about, the Reaper below it, and also my baby, the Global Hawk, right there. Now, some of the neat things I got to do. I got to help, after the first year of that first success, I got to help write the first tactics training manual for the Global Hawk, which was very interesting because we got to mix with all the other weapon systems. I got to be in the test unit at Beale and be involved in that and get to do some of the first testing ever for the Global Hawk, which also was the U-2 test unit, which was very interesting to be with one of the oldest weapon systems in the Air Force, the U-2, and also be with one of the newest weapon systems, and to see how some things change and some things don't change over that time. Now, when we start to look at UAVs, some of the successes that we've had, and these sound kind of maybe academic, but they really come out, was the first thing that we noticed with UAVs, and we started to look at is their endurance. All three of these planes have one thing in common. They fly for a long time, and they fly longer than you'd ever think. A typical Global Hawk mission, you could do the takeoff, hang around for 3 hours, go home, or go back to your hooch in the desert, as we would call it, get 12 hours of crew rest, come back in, and the plane's still flying, and it's not even close to landing yet. So to put that in perspective, we could launch the plane tonight, you could come back and hear another guest lecturer tomorrow, and the plane would still be flying that entire time with no tanker responsibility. And considering that's where you go in the future. Now, especially when you start looking at armament and how much it takes for F-16s and F-15s to refuel, that's an incredible force multiplier to have that. The flexibility you have with them is very tremendous because you don't have the limitations of the human person, and we'll talk a little bit more about that later. That provides a great capability to put them where and when you want. Optic capability on these planes is also phenomenal. If you look at the full motion video capability of the Predator, it's utterly phenomenal that at 10,000 feet you can spot a person doing what they're doing. I got to see a lot of interesting ops in the Air Operations Center. One op I saw, which is good for the good guys and bad for the bad guys. They were tracking some bad guys over there, and one of the ways they found them was a group of them would get together and do barbecues on the deck of their house. Well, it's very interesting to watch full motion video and see how bright a barbecue fire is on an infrared camera. It makes for a very good target for the good guys and a very bad target for the bad guys. They don't have a porch anymore. They took care of that when they lased it, and they brought in a Strike Eagle and took care of a bad cell over there. But what was interesting about the Predator on that was it monitored the house for like 2 days straight. They rotated out 2 Predators, and they were able to hang over there. So it wasn't you had to go over 1 second. You could go over there and stay over there and keep looking. Keep a perspective. Think about somebody watching you for the next 2 days all the way through the weekend. And every time you step outside, they can track you where you're going. Now, the other interesting thing about the Predator in particular was the weaponization of the Predator was not some grand master plan. It was done on the fly, so to speak. It was done very quickly. I talked to a couple of the engineers who did the first weaponization. There was a lot of jokes that the first time it fired off the rail, a lot of people weren't sure whether the wing was going to rip off with it or whether the weapon would even separate. But it was very successful, and it grew into the MQ-9, which the MQ-9 is now, they're building lots of MQ-9s. Other countries want to be able to fly it, and it can carry a tremendous amount of armament. You put up two or three Reapers, you have more capability than a lot of F-16s and Strike Eagles that can stay for a long, long time. And when they integrate together, they make for a very deadly force that a lot of people know of overseas. Two stories on the Global Hawk I'm going to mention. I'm going to throw out the cool stats that we got from the war, but then I'm going to kind of tell a little bit about what the human side of the story was. One of the first stats for the Global Hawk was we had the opportunity to be involved in 55% of the integrated air defense targets that came up as time-critical targets. That means a target was found short notice, and it was an IADS target and had to be taken out. Well, what was interesting was, and those numbers have been published publicly, is that was a big deal, that over half the targets, and the reason why that happened was the Global Hawk was airborne so long, when in doubt, the Global Hawk was airborne, go take a photo of it, let's get the coordinates, and pass it on to bombers and fighters, and go take out those targets. Well, what was interesting was one of the main things that precipitated that was a good friend of mine, now Lieutenant Colonel with then Major Mark Williamson. He was actually in a laundry room doing laundry over in the Air Operations Center, and a colonel came in, and he was doing laundry, and they got into their discussion with each other, and I hope the laundry room was classified, but they started talking about the fact that the colonel was actually one of the chiefs of the time-critical target cell in the Air Operations Center. And he was very unhappy because they had a lot of bombs on bombers. They weren't dropping on anybody. And Mark was equally unhappy because they were taking a lot of images in Global Hawk, and nobody was blowing them up. So the chocolate and peanut butter story sticks pretty well. They agreed, this rest of the stories, they agreed to get together on the air operations floor the next day and got together and started trading information. And they were able to help set up some data links between the systems. And that's where that statistic comes from. Two guys in a laundry room talking about, you have images, and I have bombs. Let's try to get together. And it became a very successful, important part. I was practically tackled by an F-16 pilot 6 months later at a tactics conference when I introduced myself as a Global Hawk guy. You think you're going to stay in the back very quietly. And he about tackled me. He says, I want to know why I was able to get targets every time you were flying. He had actually been involved in the first briefing when some F-16s were briefed that they were going to guard the Global Hawk when it was flying. This did not go over well with the fighter pilots. Now, it didn't go over first, but when a lot of the fighter pilots, and I've talked to a lot of them over the couple of years, when they found out that we could generate a lot of targets for them, they were very happy. Some F-15 pilots I know, when we were developing support tactics, they enjoyed us because we were bait to them. They liked us because we would be a high-value target, and people would want to come after us, and that was targets for them. I don't know how I felt about being bait for them. I mean, we joke in the Global Hawk that if I get shot down, the only thing that gets hurt is my feelings. So it's not like I'm in personal danger, but we still took a little pride that we didn't want to get shot down that much. So that was interesting. That was the first one that happened. The other one, we were involved in some SCAR missions with the F-15 Strike Eagles. Those were strike armored reconnaissance missions. The Strike Eagles would go into these SCAR boxes, and they were basically cleared to laze and look for anything that they needed to look at. Well, Mark Williamson, again, Nukes, and another officer over there, they actually said, why don't we have the Global Hawk go in and image the area, and we'll pass any data on to the Strike Eagles and see what success we have. Interesting, they took this to the intel cell side, and the first response from the intel side was, you can't do that. Why can't we do that? Well, you have to have a second source of information to be able to pass to a strike target, or therefore it's illegal in an act of war. Okay, well, here's the scoop. The Strike Eagles are going in anyway. So it doesn't matter whether we give image or not. They talked with the intel officer. In fairness to the intel officer who first said you couldn't do it, he actually came back and said, not only can you do that, I've changed my mind, I can help set up a data link, direct line, to be able to help that. So he turned around. It was about 2 days later, they did the first direct SCAR support mission. The first day when the Iraqi Republican Guard was doing its counterattack from Baghdad, the formal statistic in the public release form was 70 tanks and 300 vehicles were killed the first day. That was the success. Now, part of that success was the Global Hawk was able to be flexible. They would take targets, and I got to fly some of those missions. Our targets were not passed on 24 hours later. We look back at Cold War, Vietnam and Korea wars where we would take a picture, 24 hours we would go in. We would take an image and the strike eagles would be there in less than an hour. Now, unless they're moving that fast, they're not that far. And so we actually were able to do a timely strike integration with the strike forces and have tremendous success. And that was one of the successes we grew off of. The interesting point about that, it was pushing a new paradigm against older paradigms, and we were very successful. And that is still in part of the tactics today if we ever have to do another force on force. Now, planes look really fancy, but that's not where I live. This is where I live, in the ground station. If you want to find pictures of the ground station, it took me about a couple days to find these 4 photos because there's lots of pictures of the planes because they look really cool. Ground stations don't look very cool. Ground stations look like a big computer rack. I was a little bit dismayed when I first went into my first ground station. I was thinking Buck Rogers and all kinds of fancy screens. I went in and had very disjointed screens that did not look very well together. The bottom left-hand corner actually was my home. This is actually the ground station that flew AV3, which is here. And you can kind of see the clip-ons and the older screens. And he is flying with a mouse. The Predator in the upper right-hand corner, that's got a joystick, which makes you feel a little bit like a pilot. The Global Hawk's a mouse. So we called it mouse time when we flew. And we would make jokes about my mouse, your mouse. You have to check your ego. When I became a UAV pilot, any ego I had as a pilot went out the door. I finally just decided to learn all the UAV jokes so other people couldn't tell them to them. And I would challenge pilots, come on, tell me a joke. What's the difference between a pilot and a UAV pilot? What's the difference between a duck and a UAV pilot? The duck actually gets off the ground. Yeah, I get it. I mean, you hear them all. You hear them all the time. Now, in the upper right, left-hand corner, this is actually what's called the mission control element for the first Global Hawk. There's a lot of comm equipment around it, but people aren't going to put that on nice poster boards because that's not sexy. That's not attractive. The plane is very attractive, but a big computer rack inside is not. Now, this screen actually is the first major step for the Block 10. This is what's called the Block 10 setup, which is actually, this is ACTD, Advanced Concept Technologies Demonstrator, and this is the first production ones which are now flying. That's one of the few release photos I was able to find to show what it looks like inside. A lot of computers, and this is a generic screen capture because now you're flying the plane from a screen capture. And so now I do have to kid. I did have to call my mom after I first started flying and explain that when she told me that playing all those video games wasn't going to do me very much in life, that perhaps I was a little bit wrong, that perhaps the video games were helping a little bit. Now, my kids are in the audience. This is not permission to play extra Xbox 360. You still have to do your homework before you do that. But we are allowed to play a little bit in my house. Now, a couple interesting things about operating from a computer system is that one of the things is that I wanted to fly an actual mission one day, and I logged into the computer, and it didn't come up. It said wrong password. Checked the caps lock, standard stuff. And we found out that while we were trying to get the plane airborne, the password had changed. We were in a unique situation. I was in that chair, and we didn't have the password. So we actually went through a 30-minute gyration to find someone who had the password. And then when we got the password, my first instructions were, well, we need to write that down because we can't have this happen because there was actually a weird combination stroke that actually would lock the screens. And it was actually an emergency procedure almost to learn how to unlock screens because that was kind of important to not have your screen lock up when you're flying it. Not that the plane's going to turn upside down automatically, but you just feel good that you can see the plane. And ironically, I had a conversation in the shelter. The comm guy turned to me and says, well, you're not allowed to write down passwords. And I'm like, well, dude, you're going to have to write this password down. And the funny thing is that not only do you have a password for these screens, it's a separate password for this screen. It's a separate password for that screen. And so we actually were able to convince them that this is a cockpit, not someone's office, and they needed to write screens down. Now, it's kind of humorous, but it's an interesting difference when you get into that world. Most of our maintenance folks who actually took care of us were not your mechanics turning wrenches and working. Most of your folks were comm folks, communications folks who came in and lived in a very different world. So it was really interesting and fun to work with them because they were now in an ops environment that a lot of them had never been in before. But it was a lot of fun doing that. And if you get really tired, you can order pizza, which you can't do in a normal plane. Hey, you use what you get. Use what you have. I mean, if you can order it. Of course, there was always questions about you'd have to go out to the gate. Who's going to fly the plane while you're getting the pizza? So that was always a challenge. Now, stepping on a little bit, I want to talk a little bit about some of the things you trade off. One of the first things you trade off when you get a cockpit on the ground is that your human limitations are going to change greatly. No longer are we limited to 9 Gs, like the 16, which limits you to a certain amount of Gs. One of the philosophies, and I know there's a lot of ex-aviators in here, is that you can build a SAM, a surface-to-air missile, and it can pull 50 Gs, and you can only pull 9. Well, now you can build planes to pull any amount of Gs because you're on the ground, and unless you trip over or something, you're going to be fine where you are. So you don't have to have that limitation, which is greatly different. You also are not limited by crew duty day because you can change out people in the ground station. We actually started doing some scheduling at Beale, and what we found out was instead of the traditional pilot schedules that we would schedule on, we found it was almost more effective to look at a doctor or a fireman type scheduling, augmented crew, because that made more sense than a typical pilot crew. Because pilot crews are built for one crew to get in the plane, do a mission, come down and land. Well, now we can rotate and go through the mission. And so that was very different. Another area that will be interesting to see how we change is what are the actual requirements for a pilot to fly a ground station? I mean, I was pilot qualified when I showed up, but truthfully, if someone doesn't have a leg, they could still do exactly what I did. So it'll be interesting to see where we go with pilot qualifications. The Air Force is starting a new track. They got their first instructions to have first UAS operators start UAS training, and they will be going directly to Predators within the year. Part of that is because the orbits are growing so much in the Air Force, you can't produce enough pilots. You're going to have another source. Also, the Air Force is formalizing very smartly. They realize that you can't have just a guy go do one UAS tour and then leave. You have to have UAS operators that go from lieutenants all the way to commanders and be UAS commanders. So we're going to see our first generation of lieutenants and captains that 20 years from now will be your squadron commanders and your group commanders, and 25 years from now, your colonels and your generals, it will be UAS operators. So just like the Air Force constantly changes, they'll continue to change in that area too. The other area you see a big change in is size. We've spent 100 years with cockpits making them smaller and more efficient. HUDs got better, CRTs got better, flight management systems get better. Everything's arranged around cockpits. If you want to see nice cockpits, look at a 777, a 787. It's magnificent how everything surrounds you. Well, we can actually now change some things. Now maybe I can put a big screen in front of me. And I mean, I am a computer geek, so maybe I want a 24-inch, maybe I want a 50-inch. Maybe a cockpit is now me sitting back at a console and looking at a wide wraparound screen around me. 100 years of getting smaller, more efficient, we can now go a complete opposite direction in how you build a cockpit. No longer is size a limitation. Now you have limitations of field of view and how you want to move things around. Now, those are two good things you gain, but there's also things that have become challenges. Comms. I'm not going to talk too much about comms because that's a limitation on the plane, but the same problem you have with anything where you have communications, you're going to have bandwidth limitations, you're going to have limitations of everybody sharing those frequencies, but it's going to be very important how you develop comms because that's how you talk to the plane. That's my stick to the plane. Some of my most harrowing moments was when you would lose contact with the plane and you would sure hope the plane was doing the right thing that it was supposed to do. I know we lost link with the plane one time. It's very interesting to call up international air traffic controllers and ask them if they have the Global Hawk on their radar screen or not. Once they say yes, you quickly hang up. So I don't know what was worse, the fact that I hung up or the fact that they would talk to me. You know, I mean, you hope the bad guys don't, hey, we can call up and just do that too. So, but comms will be a challenge because you have to be able to talk to it. Situational awareness. We found out, I know in the Air Force especially, and talking to a lot of my Army friends that I work with now, situational awareness, eyeballs are very hard to replace. We do not have an optic yet that can replace the eyeball to look around. And also I lose tactile feel with the plane. I lose the smell. I lose the roll. There have been cases of disorientation. Now, it's not the leans where you think you're turning left when you're turning right. The disorientation comes to the fact that the plane is not flying where it's supposed to on your screen. I've had that happen before where I thought the plane was turning one way and it was turning the other. The one time I did mess it up, I was on the border of a country that you wouldn't want to go into. I started to turn the plane and I got distracted and I started chatting into a chat room and monitoring some other things. And thank goodness there was a brand new airman, brand new sensor operator sitting next to me. So I'm a lieutenant colonel, instructor, evaluator, commander. He's the brand new airman. And thankfully that airman tapped me on the shoulder and said, "Sir, do we really want to go left into country X?" I turned around to avoid the international incident, which I didn't know about yet. And sure enough, we were turning the wrong way into a country we probably don't want to be into. I told the airman, "You're right, we don't want to go there." Quickly did as many mouse clicks as you could in a heartbeat. Turned the airplane, made sure the airplane was turning. Global Hawk doesn't turn that fast, only 15 degrees of bank at a high altitude. So I was able to turn the plane. But that's this kind of situational awareness. When you're an actual plane, you kind of see where the plane's going because you see it in front of you. So it'll be a challenge how we build situational awareness for the next generations, because you have to have that feel, and it'll be different feel and different responses that we have to go through. Autonomous logic. I've spent countless hours between the engineers who want to design the 100% autonomous airplane that we don't need a pilot because our computer will do everything, to sitting with people who want to design the human in the loop, and autonomy is not good for anything. And we constantly go back and forth between them. What we will have to design is autonomous logic that pilots understand and can control with a mix between the two. But both paradigms have problems that you need a mix to be able to balance between the two. And it's interesting about autonomous logic is that we are getting into almost a artificial intelligence level of decision making, because one of the jokes when I went through training, it wasn't so funny when I was in training, was one of my main instructors would kid me, the first thing you do in an emergency is get your hand off the mouse and let the plane do what it was supposed to do. That is very hard, because what do we teach pilots from day one of pilot training? Fly the plane. Whatever you do, just keep flying the plane. Well, now we teach guys, well, get your hand off the mouse. Don't override it. Almost every situation I saw in the Global Hawk that got pilots in trouble, there were pilots on override that made mistakes. I never saw the once in the 5 years, and if anyone from North Grumman's out there, you can give me a little tip later on, help me out here. But I never saw the Global Hawk make a mistake. Always flew exactly where it was supposed to go. It was pilot override that they were getting into trouble, because you get into troubles with autonomous logic. Now, first generation autonomous logic, it's interesting the development going on with the second and third generations already. Termination logic is the other thing that will always be a challenge in UAVs. A UAV is going to have to land somewhere at the end of the day. Interesting enough, one of the ways the Global Hawk is designed is that if the plane sends itself around and has certain parameters to land, it'll send itself around if it doesn't see those certain parameters. Well, one of the first missions when they were testing Global Hawk, it would go around, and then it's supposed to go around, and it'll land. And at a certain point, paying attention to the fact that it doesn't meet those parameters, or it'll just keep sending itself around, and then it'll land wherever it runs out of gas. So they were testing at Florida, and the plane got sent itself around, because what was interesting was there's two radio altimeters in the Global Hawk that help it land, helps it come down, and it senses its sink rate. Well, right off the runway at Eglin, there's a big ditch before the runway. So what the plane sees when it's coming down, it sees a sudden change in vertical velocity. And so what does the plane do? Well, that's not good. Something's crazy. We need to go around. So they sent it around, and then the pilots would put it back on its normal logic. Well, on the normal logic, it senses the problem. They sent the plane around about 3 times talking to the pilots who did the mission before they finally had to leave it on what was called the C4 logic and see if the plane would actually disregard those parameters. Now, what's interesting, that's not the kind of parameters you flight test, so they got to do a couple test points and actually leave it on the logic and be able to land. But it'll always be interesting. You're always a little more motivated when you're in the plane to land it. It'll be very interesting to see how we handle termination logic when you're not in the plane. We used to joke there was 2 options. 1, you land it, or 2, you give it to someone else, and they can land it if your shift is over. I wouldn't really do that. So we did make jokes that if you ever were in a crash, could you hand it off in time? So I'd like to go through now some of the big challenges, and I'm going to hit through these kind of slowly. Is that as we build those into where we're going, one of the first major challenges is going to be sense and avoid. I get to work on a project, integration of the national airspace, and that's very important. But even more than integration of the national airspace is that our airspace, where our combat forces will be when they deploy, is getting busier and busier. If you look in the paper, and I follow a lot of the UAS news, everybody, the Army's buying them, the Marines buying them, everybody's buying a lot of unmanned aircraft systems. And we're going to need to not just a single sensor, but how we integrate UAVs across the board, it's going to be a busier and busier airspace. Now, ideally, the sense and avoid logics and procedures and parameters that will have to be developed for UAVs will have a dual purpose to be able to integrate into the national airspace and to be able to integrate into combat ops. Now, I do mention that integration in the national airspace isn't what a lot of people think. The Global Hawk doesn't need to go into Chicago next week and land and pick somebody up. So it's not like we have those kind of problems, but there are a lot of training areas, and when you start getting into a lot of other missions like Border Patrol and other areas, it will be important to integrate. But the same procedures will be there for combat more importantly. Weaponization. We've seen the Predator be the first of the weapons to have weapons put on it, but if you start looking around, there's many other weapons that are starting to design on UAVs, and a lot of countries are looking for more lethal UAVs to put different weapons on different weapon systems. One of the challenges that will present itself is that at what point are you going to trust HAL, if you're an old Odyssey fan, are you going to trust the computer to drop it without a man in the loop? We get into constant discussions about how far are you going to let a UAV do an autonomous mission before you let it drop a weapon. There's a lot of discussion you'll see in the papers about, does the next bomber for the Air Force need to be manned or unmanned? And the discussion is not technology. You have the technology to make the next bomber unmanned with current information. If you talk to B-2 and F-117 pilots, the computers do most of that mission. They're hands off during the drops. The question will be, it's almost as much as a political argument and a confidence argument. At what point do you still want a person in a bomber mentality where we go the next few years? Multi-aircraft control. One of the other main challenges, and you see this over and over again, will be we are starting to fly so many UAVs. You are not just going to be able to have UAVs, one guy flying one plane. There are going to be multiple missions where 2-3 planes will be flying one mission. And I know the Air Force itself cannot produce enough pilots, and even with the new UAS operator track, you won't be able to keep up with the growing demand. There's going to have to be a push for one person to be able to fly multiple planes. Now, this is very interesting because never in aviation history have we ever tasked anybody. You go the opposite direction. Oh, you need 2 people to fly one airplane. And so now we go the opposite direction. How can one person monitor 2? And now some of that gets into 2 arguments. Are you flying 2 UAVs on 2 separate missions? Or do you give one command to your formation of UAVs and they accomplish the mission together? This will be interesting to see where it goes, but it'll also be a challenge. Civilianization. I think we're going to start seeing UAVs used for civilian operations, and I think you'll start seeing them as it's becoming very cost affordable, cost effective for civilian organizations. We'll start with police copters. Instead of a police copter being an expensive helicopter with people in it, now you can have a UAV go up and say for 24 hours and monitor. I think the future of chasing Broncos down the road, on television is going to switch over to UAVs to be able to do that. Now again, that gets into that integration in the national airspace that will have to happen as a precursor. But the cost affordability of that is going to push it to be able to do that. You then get into rescue. You start looking at when they chase people around the mountains that escape. They're going to want to be able to go after them more and more. You start looking at weather cameras and TV news cameras. I think you're going to see that integration go on for the next many years. Now, a lot of people ask me, well, Sean, when do you think they're going to unman a Delta jet or an American jet? I don't think they're going to do that for a long time. I think if you're flying airlines, you're going to be with 2 pilots for a long time. But what I think you will see is you're going to see half-manned cockpits. FedEx and UPS and cargo carriers. Right now, the technology exists if you want to finish it. You could have a half-man cockpit. You could have one pilot with the plane. He could do the takeoff with someone in a remote area, and then he could actually, the person on the ground could fly that FedEx jet or that international cargo flight. It could be done very well right now. Where you get your savings on that from a cost perspective is that if you fly 10 747s, you have to have 20 pilots. But if I half cockpit those, and if I half unman those, now I have 10 pilots instead of 20 pilots, and if I only require 3 guys on the ground to support those operations, I've gone from 20 personnel to 13 personnel. And if you ever talk to CEOs in those kind of companies and cost savings, if you could save them 1 pilot, that's a tremendous saving. You're talking immediately 25 to 30% savings on some of those. So it'll be interesting to see where we get a push, not so much from the technical, but from a monetary side. you will be able to start seeing that technology. Most airline pilots, and I have a lot of friends who are them, they talk about the fact that flying airlines right now, once they take off, they're hands off and they're plugging in information. If you look at the latest Airbus plane that came out, what's in front of the pilot is actually a keyboard that comes out. The sticks are on the side, and he spends as much time on the keyboard as he does flying the airplane. So they're not that different, even if they'd like to think so. Anti-UAS development. The reason I wrote anti-UAS is because there's a lot of different countries developing UAVs out there. And we've had the advantage with our first UAVs to operate in very friendly environments. But two things. Number one, we may not be in friendly environments in the future. And there's so many other countries with the lethality that we're going to have to look at how you also go against UAVs that are coming against us. What will be interesting is if anyone knows a little bit about the Warsaw Pact NATO days, is that they overpowered us with numbers. So it'll be very interesting to see when countries can develop UAVs at a much different, lower cost than higher-end fighters like we tend to have sometimes, is that what happens if they have 10 UAVs that are lethal coming against us and we have fighters that go after them? We will rapidly, just like the Warsaw Pact ratio, where we would run out of weapons possibly before we run out of targets. It'll be interesting to see how we look at anti-UAS and how we're going to look at the challenge of taking on other countries. There's a lot of discussion about, getting more UAVs, but as much as it's positive for us, we will have to, number one, figure out how to better protect our UAVs with protection. Now, it's interesting when I mention protection for UAVs. I've mentioned when I was in Global Hawk, we would get into discussions about maybe Global Hawk should have a defensive system. Well, the question that comes up is that, well, why would you want to defend a Global Hawk? There's not a man in there. What you're defending is the capability that the plane brings. It's a very expensive sensor, and I think you want to be able to protect that, especially at the cost of those. So there's defensive capabilities that are coming on, but we're also going to have an offensive capability that be able to project against other countries. Other countries are going to have UAS technology that is going to be offensive against us and our allies in the future. And that'll be very interesting to see how we do it. As an example, what's next? I just brought up a few examples. You have this is the X-45, which was a Boeing bird at Edwards. This was the drop of the first precision-guided munition from a UAV that was done out there in test. This is a view of what would be the X-47 coming off a carrier, the Northrop Grumman, I guess to work on. Very capable systems that have shown us a lot in the UAV world. Interesting, this is an AeroVironment. It's a hydro-powered plane. AeroVironment actually developed from a energy company, and they actually have a non-oil-based engine, hydrogen-based engine that runs. Now, what's interesting about this guy, it can carry, I think, the prototype I got to work with a little bit and talk with these guys. It's a 500 to 1,000-pound payload, but it can stay airborne for 7 days. Now, I thought the Global Hawk was Mr. Bad, being up for 24. This can be up for 7 days. This is in research and development right now, but what's interesting is every time you see UAV records being set, it's no longer hours. Now it's days. Quinitech, I believe, out of Europe, has done some development, and they're actually talking about a couple, they're talking solar-powered flights that are going on right now, and they're talking up to missions up to a month long. If you're flying for a month, you're no longer an aircraft. You're a satellite. And that's how it needs to be treated. Now, we actually got more out of talking to space guys about controls for the Global Hawk than we did a lot of cockpit folks we talked to, because it actually is much more in line. The other one I put up here, because it's very interesting to see, is I first saw this, and I thought, what is that? This actually is the latest BAE aircraft called the Mantis that Britain came out at Farnborough this year and produced. Now, if you can see, you can kind of see the size of the person back here, the size of the person up here. This is what you kind of get as a competitor or a compadre, because hopefully they're our friends still, with the Brits. This is kind of an MQ-9 level, being able to carry multi-missions. This is already what's being introduced. They have their first flight test, from what I understand, in the spring, and they're going to be going beyond that. So this is just a little bit of what's next. What I find out most interestingly is that with all the development, the biggest breakthroughs that I got to see with UAVs were human ideas of how to push the technology. And the success of the Global Hawk that I got to be blessed with for almost 5 years before I got out was there were a lot of ideas to do something different. that had never been done with the Global Hawk. So I'm excited to still get to be to UAVs. A lot of my friends who first thought that I was going to lose my career and never get to fly again, they were right. I never got to fly again after that. But it's been extremely fun getting to know this. It's a whole new world. We're going to see probably some of the biggest differences, I think, in flying in the next 10 years that have ever happened in aviation with unmanned aircraft systems. And I'm hopefully going to get to be a part of that.